everybody. My name's Eleanor Saitta. I run a small company called System Structure Limited, where we basically do one thing, which is fractional chief security officer for startups, i.e. I build security teams, and I've built probably, a dozen, 15 in the past decade or so. And so I am here to tell you as much as I possibly can if you're in the position where you have, I don't know, somewhere between 10 and 200 engineers, which is sometimes actually 200 engineers, and they still don't have any security team, but where to start and how to think about security. So I'm going to start with the thinking bit, and then I'm going to get to the doing bit, and we'll go from there. Before I start, quick, who here has a security team at work? Okay, about half the audience. And I'm assuming if the rest of you don't, who here is PM, like product or project side of things? Manager / exec? And dev? Ops engineers? Anybody? Okay, yeah. Cool, just so I have an idea of, yeah. So first I want to talk about how you think about systems. Systems exist to do things in the world. To be useful, systems need to have certain kinds of properties. Most of the properties are whole system properties. They're not like, you can't point at the part of the system and say, oh yes, that's the performance code. Or, well, sometimes you can, but then you have a different problem. So these whole system properties occur in specific contexts, right? It's not, a system doesn't exist in isolation. It has users, it has how much money can you afford to spend on this system. And all of these properties require unified effort to deliver. These are probably some of the properties you care about, right? You care that the system functions correctly. You care that it is performant on the basis of what your user needs are. You care that you don't burn more money than you have running it. You care that it's observable, and you care that it's secure and resilient. And I'm going to talk about those two conjoined because to me they're pretty inseparable as properties. So a system is one that predictably accomplishes the goals of the chosen set of people who you care about. There are probably a bunch of other people using the system who you don't particularly care about. So you have the set of users that you actually care about who are not necessarily everyone on the internet who may be trying to use your system. That you can have those people do that thing in the face of some actions by the set of adversaries you're trying to defend against. I hope no one here is actually trying to play the security against nation state games. If it is, I hope that you're not learning about security from the first time for this talk. If you are, let's talk later. That's a fun game, but yeah. And that you can predictably prevent that chosen set of adversaries from impacting your system. Because if you can't predict that you're going to succeed at preventing those adversaries, then you also, you don't have a system that you can rely on. So who here is familiar with the Resilience Engineering Association? Anyone? Definitely take a look at their work. They're looking at things like hospital emergency rooms, like aviation operations, and also increasingly at running large, complex distributed systems, because it turns out they have very similar properties. And in that world, we talk about reliability as the system doing the expected thing within the expected set of failure modes, right? So this is high availability systems is a reliability thing. Resilience is what happens when you leave the design parameters of the system and you're now trying to deal with something that you had no idea what was coming, but okay, let's try and keep the system up anyway. Okay, we just got, somebody forgot to replace a critical part. Well, we still need to land the airplane. This is where you get into resilience. And this is almost always a property of humans, because this is a property of, okay, how can we use this system in ways that it wasn't anticipated to be used? Every major outage is often the process of going from reliability to resilience, especially if you end up operating in a degraded state, et cetera. If your system is big enough, you're almost always pushing into resilience territory somewhere. Both of these are, both security and resilience are things that you can get to from principle-centric design and principle-centric architecture. Some of these are technical principles, some of these are human process principles, and I'll go through a few of each. Obviously, there's a lot more. This is kind of, I'm not going to read this since it's just where we're going. So state and logic. If you have a service, it should either maintain persistent state or do computation. If you have services that both maintain persistent state and do computation, they are much, much harder to debug because you now have to, the result of a computation isn't predictable, the result of a store action, et cetera, isn't predictable. So you want to split those so you can at least test them separately. In general, complexity is the absolute enemy for security. The more complex your system is and the more complex any component is, the more complex the overall system is combinatorially. It is not, if you have one system with one bug and one system with one bug and you hook them together, now you have two systems with at least 3 bugs because there's going to be mismatches between the two. If you have 20 systems, you have possibly 20 factorial bugs. So you want to make them as simple as possible so they're more predictable. You want to make them immutable. You want to have state in as few places as possible. If you have, like, obviously, a running process has state. It has state in memory. But the more frequently you can drop that state out and get back to 0, get back to that predictable starting point, the better off you are. If you are running heavyweight VMs that you patch in production or you update config files in production and you end up with config drift and all of this kind of stuff, congratulations, your system is now wildly more unpredictable. You don't know actually what system you're running where. If you blow everything away to a clean state, I don't know, probably no more frequently than every 5 minutes, but I've seen systems that do it faster, like even with heavyweight VMs. Now you know where you are. Also, the more ephemeral your systems are, so great, you have a web server, it gets compromised. Well, that web server has a 2-hour lifespan. That means the attacker needs to rerun their exploit every 2 hours if they want to stay in that system. Exploits are often loud. Now you have many, many, many more possibilities to catch that exploit being run than if it's, okay, run it once, stay in the system, stay resident there for 2 years, whatever it is. So yeah, both of these are design choices that you can make that will make it much easier for you to maintain the security of your systems separate from whether or not they start out at, from whether or not they have vulnerabilities. Immutable systems, and by this I literally mean ideally no writable disk. If you've got a VM, fine, you can have a no exec, no root scratch disk, but nothing that actually can run code can be changed. You just actually redeploy. That also means that an attacker now has to live in memory, right? They can't write, they can't download tools, write them out to disk. You've made their job much, much harder. Minimal canonical state. Ideally, you have at most one source of truth for every piece of state about the system. We almost always exist in a state of sin here because, okay, you have a cloud environment. I have all of my IAC code. My IAC code is canonical in theory, but also the actual running cloud configuration is canonical because that's what's actually running. This means that you need to have active bidirectional cross-checks, right? You need a closed loop control. So ideally, that's not just, fine, we have Terraform pushing state out, but then we also have inspec or something validating that, the system is in the state that the Terraform told it to be. You're not going to get there immediately. Although if you're starting out, you can start building a lot of these, you can start building in this way from 0, and it's a lot easier. You will also catch a lot of deployment issues as you go, et cetera. So there's benefits if you can start working that way. But yeah, as few stores of state as possible. Caches are not canonical. So you can get away with caches as long as you have appropriate, checks on them. Bug mitigations. This is the mitigator. The mitigator raises the bar until he can't see the problem anymore. Mitigations always fail. So do not, if you have let's say outputting, like a cross-site scripting problem. One of the ways that people try to deal with cross-site scripting is, we'll try and validate the input so it can't contain anything that could run a script. You're always going to miss something. So instead, you make sure that when you write those strings out into a page context, they are encoded in a way that they cannot be executed. And you do it right at that point. And then it doesn't matter if you've missed something in the data, some path didn't have input validation, you got data from a third party that was dirty. You don't have to think about that. So in this context, output encoding kills the entire class of injection vulnerabilities. The same with parameterized queries. Anytime you have the choice between applying a mitigation, say address space relocation, like address space randomization for C libraries, which is a mitigation against buffer overflows, but it doesn't actually work in the end because as soon as we shipped ASLR, people found ways to get around it. And it took 6 months, a year for people to find the bypass techniques. And then everybody just copied that. And now everybody was back to square zero instead of, I don't know, writing in a memory safe language in the first place. So yeah, if you have a choice, always kill bug classes. And kill them at the framework level. Never try and, don't put your fixes, each time I write this function or a function of this type, I have to remember to put this thing in here. If your framework doesn't already do it for you, or your language doesn't already do it for you, either change languages or ideally pick a different language originally, or patch the framework or add your own library that fixes this problem for you. You want to make things as easy as, you want to have your developers do as little incredibly sensitive coding as possible. So if you have to do that, do it once. Segmentation is great because after you've been compromised, you will always eventually be compromised. The attacker probably still needs to get from the place that they compromised a system to somewhere else. The more ways that you can stop them getting from point A to point B, the more likely you are to frustrate their ability to do the thing that you don't want them to do. So that means between systems, between instances, between environments. So service level firewalls, creds that are per instance rather than per service. So that like, yes, service A is talking to service B. This instance of service A has unique credentials which are bound to the lifetime of the system. So once that, when we roll that node, then the credentials die with it so that if the credentials got leaked, they're no longer valid. We don't have to worry about it. Vertically within a system, so things like AppArmor, traditional system hardening, traditional least privilege, and then time-based, short-lived secrets, short-lived hosts, et cetera. And then obviously making sure that, dev and prod are actually different environments and that you don't have the data that you're trying to protect in prod. Oh yeah, but it's also, we just have this copy in dev because we need to test on real data. No. So now let's talk about people. If you have the choice to declare a configuration rather than programmatically programmatically creating a configuration with a set of steps, humans are much, much better at understanding the end state of a declarative system than a programmatic system. So it's much, when you read a declaration for what the state of the system can be, you will notice the errors much more easily than you will when you read the programmatic steps to get there. So if you have the option of using a declarative tool, use a declarative tool. Parser generators are great. There was a whole movement called Langsec, which basically was like, second to memory failures, parser failures are the most common source of bugs. We are incredibly bad at writing parsers. We're really great at writing language specs and reading language specs. But if you're manually writing a parser, just stop. Just get a parser generator. Your life will be so much easier. And especially get a parser generator designed with security in mind so that you can prove at the tool level, not in the code that you're writing, that there's a proof that this will be a correct parser in all cases. And when I say parser, I mean you're accepting a string, any string, that you're doing something different on the basis of the contents of that string. That's a parser. Not necessarily a complicated parser, but state machines also. How many of you have to deal with business logic that has big, complicated state machines in it? How many of you know whether or not that business logic is actually correct? How many of you know the business logic for your company and can point to it outside of the code? I've never had a client who can do that, including banks. They know what it's sort of supposed to be, and then there's all the edge cases, and those are really only in the code. If you've declared the state machines, you are a lot closer to being able to actually understand how your business runs, as well as dealing with oh wait, somebody started this transaction in a legal state, but the state machine, we never thought to write the code that says, oh, we started a transaction at the confirmation stage, like a money transfer at the confirmation stage. well, yeah, we just accepted it and we moved the money. That kind of thing is really, really common. Compromise is inevitable, right? So you should design for it. Something is eventually going to fail. Something will get owned. You can design your systems to handle more and less predictable failures. But part of the way you do that is assuming, like, you look at your layers of controls where you have, this is a thing that prevents someone from writing to the database, and this is a thing that someone prevents, someone from getting the creds to write to the database, whatever the control stack is. Assume any given one of those layers is going to fail, right? Maybe don't assume more than one layer will fail, but assume at least one layer will fail. Is the whole system still secure? This is defense in depth, but this is how you actually do defense in depth, is you look at those control flows. Also, you get to choose the system that you have when you're responding to a compromise, right? What would you like to have had during your last major incident? You can think about that beforehand and design for it. A lot of this means visibility. And this means visibility not like, great, we have these log files and they contain all of the events that happen in the system and no one looks at them because they're not human readable. On the other hand, we just have a Slack bot that tells us every time somebody SUs in production, because that shouldn't happen very often. And like sometimes fine, we're in a situation where sometimes people need to SSH into a box and do something. Wait, but Bob's on vacation. Why did he just log in? That's weird. Now you've noticed a thing. So those kinds of socially visible risky events are really, really useful early warning systems. Human error is also an absolute constant, right? Your staff and your users click on things for a living. That is their job. Their job is to click on things for a living quickly. You cannot train your users out of clicking on things because that is their job. You cannot yell at them to make them stop clicking on things because that is their job. You can make clicking on things safe. So do that instead, because that actually works. If you do not already use YubiKeys, switch everything over to YubiKeys. Not passkeys, YubiKeys, and U2F mode, or any of the other tokens that are U2F tokens, because that actually stops phishing. You just get to stop thinking about credential phishing. Great, problem solved. Now you can stop doing phishing training that alienates your users and makes them fear security. Get Word and Excel and all of the other common malware vectors. You definitely don't need the desktop tools. You probably don't need them at all most of the time. Just get rid of them. If you can't, if you still have to yell at your users, get goats. You'll yell at them too, but the goats are funnier. It's still not going to work. They're still going to do what they want, but yeah. Decision-making at the edge is incredibly important for resilient response to incidents. So ideally, the person who is committing the code, the ops engineer who is changing the thing, is empowered to make most of the decisions about their work without cross-checking with anyone where it's not like a technical cross-check. And ideally, if they need to reach out to another team, like, oh, I need to talk to the DBA, I need to roll this database right now, they can call that DBA directly, immediately, without having to go up a chain and back down a chain. Because, and you have the social relationships in place to let people do that. These are the things that let your team actually respond to incidents, whether they're security, reliability, perf, whatever, quickly. Communication and coordination are much more important than control as a manager, which is terrifying if you're a manager. It's even more terrifying as a security person, and yet it is the only thing that actually works. How many people, if you're managers, know, I guess if you're in Europe, you probably have a better idea, whether or not your teams have taken all of their vacation? If you don't know this about your team, that is a problem. Because you have people who are burning themselves out. If you work in a mission-driven company, you have an even bigger problem, because your employees are now motivated to burn themselves out. If your team not only isn't taking their vacations, but is also scheduled for 100% of their time, right? They don't have Slack in their schedule. Great, your team does not have time to fix all of the small things before they become big things. Have feature velocity caps. Push back on product and be like, no, this is our, yes, I know we have more time available. We're not doing it, Ideally, you can do this without hiding it from other parts of the org. You know, almost every dev team I've seen just kind of lies about how fast they can get work done because that's the only way they can get maintenance time. That's really dumb. You should fix that. Stop lying to yourselves. Okay, so let's talk about the more practical side. Let's talk about scope for security when you're starting out especially. You care about the software you write and your production infrastructure. This is what we all think about. You care about your laptop fleet and your IT systems. One of the things that I end up saying a lot to clients is, yes, I absolutely trust all the engineers who work here, but I don't trust their laptops. You know, that shit does all sorts of stuff. And maybe it's the engineer doing it sometimes, but even if you just trust everyone implicitly, don't trust their laptops. Cloud stuff you've forgotten, you know, like the number of times I've seen like, oh yeah, and then we have Zapier here. And oh yeah, like it has production DB creds. What? You know? Oh, and like, yeah, half of marketing has Zapier creds because they also use it for marketing. We just use the same account. Okay. Yep. The tools that your employees use to get work done, not the tools that you've told them to use to get work done, but the tools they actually use to get work done. Visual Studio has a great plugin infrastructure that can do anything the engineer can do. And those plugins can, like literally they can do anything the engineer can do. Do you know what plugins your engineers have installed? Most people don't. You have to think about your products and services from your customer's perspective, right? You have a duty to your customers to think about security implications for them, not just for the company. And how you run your operations. This is all of the like, oh yeah, the CEO told me to go buy a gift card scams. You know, this is all stuff that you have to care about. When to start? For the product, you should be thinking about risks for the users and for the company early. You should know what can go wrong. As early as possible, make good language and framework choices that are designed to make your life easier. Do not write your own authentication layer. There are plenty of companies that will do that for you. Do not host your own authentication layer. Like, yes, I know that there are great libraries. Just let Auth0 do it. Because now, when you have a password leak, you can blame them. Also legally, this will make your life much easier. Just don't do it. Even more for stuff like crypto. The less data you have, the less risk you have, right? The best way to reduce your legal exposure in the event of a data breach is to not have data. So think very carefully about what you actually want to keep. Try to avoid, as I know has been the fashion for a long, we'll just keep that. We might need it later. You know, product says they kind of want to have that because they think they might do something. No. Business case justification for every piece of PII you keep. Do this stuff immediately, then figure out if it's a real product. Don't bother with anything else until you know it's a real product. For a company, make sure it's a real company. Do not worry about security when you're pre-A or before 10 technical staff, unless you fucking up is going to get your users hurt or killed. Seen that too often. Or, you know, like some other extreme negative effect. Don't worry about it immediately because this is going to take a lot of your time and it's going to change the way you do development and stuff. You probably don't need to do it that early. Do start at pre-B round. Preferably start it immediately post-A so that you have stuff in place pre-B because it will make diligence easier. Ironically, if you have non-tech funders, you need to do this earlier because they are going to outsource technical diligence, including security diligence, and you will get barraged with checklists rather than having a call with a tech-oriented VC where you can say, well, we're doing this, and then he gets a good smell, and he's like, yeah, cool, whatever, you know, spend some more on it later. Buy as few SaaS systems as you can because you're going to have to maintain all of those, and you're going to have to track all of them down. Try maybe not giving people the Divi card or whatever that lets them just put stuff on the corporate card with any review, without any review. So just keep that stuff as simple as you can. So when you're starting, if you do not already have an IT engineer and an ops engineer, you need to hire both of them. If you are not in a position to hire an IT engineer and an ops engineer, you're not really in the position to start doing security work because you're not going to have the bandwidth to actually start implementing it. Make sure that you have actual backups that are tested. I would say 95% of my clients, there has been some production critical system that they have not had backups of. And these are not small companies. These are companies that you have heard of. And still, oh yeah, we were, quarterly, no. Get backups. AWS and GCP both have tools where you can put something into long-term storage, and then you can set a minimum retention time, so it cannot be deleted for a year. And then you can remove your ability to change the minimum retention time. And for example, with AWS, if you close your account, you close the entire account, they'll say no. Sorry, we can't close your account for a year because you need to keep paying for the storage for that year because we can't change it. Now, you can often get around that, but that means sending yourself and lawyers to an office level of change, which is not a thing that ransomware can do to you. So you now don't need to think about that, or at least not thinking about the data deletion part of it. Get everything you can on SSO, like everything that will just plug into Workspace for SSO, do that. Get YubiKeys for everybody. Try to avoid having Windows boxes. Definitely try to avoid both having Windows and Macs. Definitely avoid having Windows, Mac, and Linux desktops. Dear Jesus, you've now got 3 times the work, except you actually have 4 times the work because you need to make sure they're all to the same standard. You don't have the money for that. Just pick one. Get some kind of fleet management. If you have a network, Thinkst Canaries are great. They are the only security product which I recommend by name because they actually literally take 5 minutes to set up, and then they don't fucking bug you until somebody pokes them in a way that they shouldn't. And then you find out about it. It's great. They're also a great tool for when you're at the point where you're getting more complex internal pen tests. They'll let you know where the pen test team is, which is a lot of fun. And get some kind of basic log centralization. If you don't have log centralization, you can't figure out what happened in a breach, which means you can't figure out what data got taken, which means you can't figure out what users to notify, which makes the conversation with the ICO really annoying. So get basic log centralization, even if no one is looking at it. Just get it stored somewhere. Governance. If your CEO, CFO, COO, CTO are not on board with security, nothing's going to work. That is an absolute prerequisite for any meaningful security work. Someone has to own security. This should not be the CTO because they do not have time to think about security. And security does, in some places, work at cross purposes with the rest of technology. That person who owns security should ideally be a peer. They should not be a report to the CTO because they need to be able to tell the CTO no sometimes. Now, ideally, they never actually say no. We'll talk about that in a minute, but they need to be able to. You also almost certainly do not need, and this is like, obviously I'm self-interested because I am a fractional CISO, you need somebody with a bunch of experience. You do not need them full-time. You are not going to be able to use them full-time for a while, but make sure that you have access to that. I don't care where you get it, but finish your vegetables. If you start a migration, finish the fucking migration. Do not build legacy systems in the first 3 years of the company. Actually finish the work that you start. Unless it's going if it's going to kill the company, fine. If it's not, finish it. It will make your life much, much easier. Think about the incentives you set up. One of the big problems I see is we have features that are tied to KPIs, and if you don't hit the KPIs, you don't get bonuses. Oh, now do this security work. It's very important. Nope. Not going to happen. Doesn't matter. You can yell it. Nope, it's not going to happen. Set the incentives that you want to get the results you want. You cannot fight the incentives that your team has. Don't try to do qualitative or quantitative security metrics. You don't have the data. You don't have the maturity. Figure out how to do qualitative security metrics well. A good description of the state of the security written by somebody who is a more neutral party is going to do a lot more use than, we have these 3 weird metrics that we have that we think, well, they don't actually relate to anything, but they sound good and they're metrics. They're definitely metrics and they're definitely security related. And that definitely makes the board happy. No, get the board to learn how to read a paragraph. When you buy SaaS tools, include the cost of maintenance because it's going to be more than you think because somebody has to manage that thing. Getting work done. Yeah, you need to be able to delay product work sometimes. Your planning process is security critical. One of the big failure modes that I've seen is companies that well, we're small, we're starting out, there's somebody who has the product vision and they just kind of decide no, you need a process because once you're starting to do security work, you now have two competing priorities, and two competing system visions, and that means you need an actual process. It can be super lightweight, but it needs to, A, be documented so that there's a meaningful way to engage with that process, and B, actually be the actual process by which decisions are made. Not, oh, we have this process, but actually, well, there's this guy, Tom, and no. Follow the process. That means segmenting high importance, low urgency work from actually urgent work, right? So a lot of security work is not urgent, right? It's like we're not owned today, but if we don't do this, we will be owned, I don't know, maybe this year, maybe not. So you need to have a way to figure out how to balance those two, which is really, really hard for startups. You need to be moving beyond single quarter planning at this point because you're going to be dealing with longer term narratives. You need a lot of cross-team coordination. Again, you should be doing this anyway because it will make your systems more resilient in the case of outages, but specifically for security work, a lot of that work is cross-cutting. Technical decision-making and architecture. How many people here know how architectural decisions are made at their company? Yeah. They just happen? Well, we ended up here. I don't know. Some things, no. Get good at that. It's worth getting good at that. It's worth having some kind of super lightweight process so that you actually know where those decisions get made so that there's a place to intervene in them. And then there's a place to cross-check so that you don't end up, I don't know, spending a year and a half developing a product that you kill in the last 6 weeks because somebody actually looks at what it does and is like, this is unshippable. That sucked. The more unified your working processes and tooling is across teams, the better, the easier it's going to be to do that collaboration. Security's job is not to be that cat. Security's job is not to say no to things. Security's job is to say, okay, that's interesting. What are you trying to get done? How can we help you get that done? And that is the attitude that you really want your company to understand for all of the security work. It's like, yeah, and sometimes the answer is, no, you can't do it that way. But it always has to be, but how can we do this another way? You want your security team to make friends, especially once you're at the point where you have an actual team. Rotate people in and out. Rotations are great for building those horizontal connections. At Etsy, I was their security architect for a year. We had free candy. There was lots of health food in the building. We had candy. And that meant that everybody stopped by the security desk every now and then, and we got to know people. And yeah, it was absolutely worth the candy budget. There are a lot of brilliant security people out there who are best kept in a basement. Do not hire those people. Hire people who know how to talk to people and know how to communicate and know how to negotiate, because especially at a startup, they're going to be doing a lot of that. You need to select for that. It is as important as technical skills for them. Do not ask the security team to do all of the security work. You need to have other teams doing that work. But ideally, there should be some resources that the security team can also allocate. So they need some way to give back. There needs to be not just a one-directional street there. Because if the security team is always asking for, oh, I need you to stop and do this, whatever. Maybe they have a pool of cloud spend that they can give out, or I don't know what it is. Figure out how the horse trading can work, and make sure security has some horses to trade with. Compliance. So compliance regimes give really useful incentives and really bad guidance. They are not. You do not build architecture on the basis of what the compliance regime tells you to do. You build architecture on the basis of what actually delivers security results, which often has very little to do with what the compliance regime would suggest, and what the business needs and technical reality, et cetera. And then your compliance team figures out how to sell that to the regulators. This is not about shirking compliance duties, especially if you're in a regulated industry, et cetera. This is about building a good system that also satisfies the requirements. And sometimes this means story time. There was a guy, I think at GDS maybe, and he built a PCI environment that was not segmented. The systems that handled cardholder data were not segmented from anything else. But what he did is he rolled those systems every 5 minutes. So basically no credit card data could be persisted in memory. And he had a long conversation with a very friendly PCI auditor. And yeah, it was fine. There are a lot of things that you can do, even in the face of regulations that seem really explicit and seem to be pushing you towards a specific, possibly not great architecture, to not do that. Security compliance must report to the CISO. That should not be under ops, et cetera. And this is about making sure that actual security is driving the way you do security compliance, rather than compliance driving the way you do actual security, because one of those works. Risk. How many of you know who your adversaries are? I mean, like addresses. Like, if you work at Google, there are a bunch of Google's adversaries where, yeah, like, oh yeah, this piece of malware, I recognize that thing. That's this one guy in China. I know who his girlfriend. You do not have that security team. You probably don't see enough attacks that you can generate meaningful statistical data about them. If you run a marketplace and you have fraud on that marketplace, which you do if you run a marketplace, that's the exception. For everything else, you have exposure. You do not have risk. This is a particular nitpick to me. I don't like to see companies making up data for metrics. So it's like, oh, okay, we have, it would be this bad in dollars or t-shirt sizes if this thing happened, and we think the probability of it happening, no. You think the difficulty of it happening, sure. You think the cost to the attacker to launch this attack, sure. You don't know anything about probability, don't make numbers up. Detection, you're gonna need to log stuff. It's gonna cost money. Try not to spend that money twice, because your ops team and your application team also need logs. Ingest is expensive. Ingest in one place that everybody can use. You need someone to look at the logs. Actually haven't checked that statistic in a while, but it's been holding around there for a long time, 210 days to find out that you're compromised. And something like 75% of the time, a company finds out that they have a compromise because either their hosting company or another vendor tells them. Don't be that guy. But hey, that's a pretty low bar. You can do better than that. That's the average. You're not going to hire a SOC in-house anytime soon. You're going to outsource. You're going to outsource to some kind of managed detection team. Which one you pick depends in part on what your growth curve is. If you don't expect to be building a SOC in the next few years, then you probably can outsource to a team where they own and run the infrastructure for you. If you do expect to be growing on that curve, then you want to outsource to a team where they use your infrastructure. There are a lot of ML tools out there for security. They're mostly crap. Detection is a place where they can sometimes be useful, but if you have an ML tool that claims that it will replace engineers, they are lying to you. It will absolutely not. It is at best an augmentation. And if you didn't log it, you can't figure out where they got in or what they took. So you need to have those logs somewhere. Capability, code, is not an asset. Code is a liability. You spend lines of code to buy features. Every line of code is an ongoing cost and an ongoing risk. Tools that help you write code faster are bad. Like, yes, if they help you write code that you know is going to be bug-free, a parser generator, the code that you're writing is the language spec, not the code that's generated. Other than very specific cases right now, you should be asking whether or not this feature is worth the code it takes, as well as the time it takes to write the code. Every tool you adopt, every library you adopt is an ongoing cost. Most technical debt slows you down, and specifically security debt is mostly debt that you don't know about, right? It's, well, we have a legacy system and we know it has problems, but we don't know what problems. The more of that you can get rid of, and the more of those legacy systems that you can finish your migrations and get rid of, the better you are. On the front end, you probably don't know what JavaScript runs on your site. There's a tool called Looky-Loo, which is great. It lets you figure out what all of those advertising, like where stuff is going, what's actually calling what. If you look at a modern website with a bunch of ads on it, you're probably hitting 800 sites on the initial page load. All of those sites can do anything they want in your page context. If you can avoid having advertising, especially on any site that actually matters, anything that a user can do something for real, including the tracking code, especially if you have like third-party code that's still loaded there, just get rid of it. It's malware. It is actively malware at this point a lot of the time. Not even like in the sense of like, well, no, it's actually malware a lot of the time. The web security has gotten a lot more complicated. You need to understand content security policies and all of the remote object loading stuff. There's a long tail of stuff. There's a Google paper on the post-Spectre web, which is still worth reading. I think there's actually a WC3 draft or something. It's worth reading just if it's been a while since you updated your understanding of the web security model. It's worth reading. Stuff that you integrate on the back end where you're serving the JS is much easier to control. You control the versioning, et cetera. Do not expose GraphQL to the internet. You don't expose databases to the internet, don't expose GraphQL to the internet. If you expose GraphQL to the internet, congratulations, you need to write canned queries and call them by hashes and deal with versioning on the client side. It's a lot of work. Just preferably don't do that. Supply chain, you also don't know what runs on your back end. How many people here know which library version they have everywhere and are sure which of those have CVEs in them? You need to be able to reproduce point-in-time builds. And you need to have an understanding of like, oh, this hash, this version, has it changed in the repo? That's weird. A release has changed without an update. Artifactory is annoying. It's the least annoying tool I've seen for having local repos and having this kind of cross-checking. It's better than nothing. Shove all your config in Git so you know what was there. Make sure that you have all of your deploys logged. Make sure that you can figure out, oh yeah, when this query ran, I can reconstruct the system it was running on. When the system gets large enough and complex enough, often no longer possible, but you should have at least some idea. Audits. Red team audits are for testing incident response. They are not how you learn what is in your environment. Do full access gray box testing. Don't hamstring the team by not giving them code access. Do an early test on an MVP and then full tests later on. You don't need to be doing full fat tests early on. Some solutions to avoid. Don't let the CTO buy things he sees in airports, especially if they're security tools. That is, good tools rarely advertise in airports. They don't replace security engineer. If it's a black box that you can't understand what it's doing, it's rarely useful. DDoS, spam filters, sure. AV, not so much. You want tools that work like the internet. A couple last things on product security. I know we're just about at time. You get to design your attacker's motivation and the problems that your attacker has to solve. This is one of the very few places where you can actually make those choices. So think about your product in terms of designing the adversaries that you want to deal with. Spend as much time engineering the unhappy paths. Understand where all of those failure modes go. Know where all of the decisions are made so that you actually get where the problems are. Document all of this so you can actually figure out, oh yeah, this is where the login flow goes today on this build. If you have to deal with non-credit card fraud, hopefully you don't have to deal with credit card fraud. If you're starting a bank, talk to me. But if it's not credit card fraud, that's a non-credit card fraud, it's a core competency. Treat it like one, build that skill early. And finally, you are responsible for the impact of your work on people's lives. And you don't get to get rid of that content. Even if those people shouldn't be using your product for the things they are, you put a product on the internet, people are gonna use it. You don't have control over that. I'm gonna give you 3 personas that you should be thinking about in the product design process, regardless of whether or not you think they're relevant. A domestic violence victim who's seeking an abortion, right? You're Slack. Oh no, we're not a social tool. I'm on more social Slacks than I am client Slacks, right? These are things that you have to think about, right? trans kids who aren't out at home, right? How does that interact with your parental controls? A union organizer, right? Well, we just make corporate middleware something messaging. Okay. You still have a responsibility to those people. They're not the ones paying you. The ones paying you may not even may not like those people. You still need to think about it. Anyway, if you're a startup, you're looking to get serious about security, come talk to me. So one of the things which is useful here is to figure out which things you really care about, right? If your ecosystem is segmented in a way where you can say things about like what should be getting traffic from what, right? Figure out the things which are big red flags like, hey, somebody just tried to SSH into a bunch of these boxes from an IP that is not our one bastion host. Alert on that, right? You're not going to build out alerts for everything. Do those first. Make sure somebody actually looks at the alerts you really care about. That's one of the reasons why I like canaries, is they don't generate false positives. Like sometimes I get a ping, but it's an engineer. Like, what's this box? Great, I wanted to know that he did that because he's probably doing that elsewhere, and maybe that's totally fine, or maybe it's a problem that I need to have a talk with him. So yeah, figure out like high value alerts that you can get, and then get the outsourcing done when you can. Word, Excel, and Acrobat are the primary malware vectors still. Like 90-ish% of the time, if you have an owned laptop, it got owned via one of those, unless an employee actually intentionally downloaded a thing and ran it. If they clicked on a thing and then they found themselves owned, it was probably one of those three. Get rid of those three, you've gotten rid of the vast majority of your malware risk. Talk to me. Yes, that's a complicated problem space. It's a fascinating one, but it's a complicated one. Thank you.